Recording in progress.
Dear Maria, could you please switch on your voice? We cannot hear you right now. Sorry.
Can you hear me now?
Yes, we can hear
Okay.
clearly.
Okay, sorry. So let's start again. Welcome back, everyone. My name is Maria Célia Portela, and I'm speaking from Brazil, and I'll be your moderator for this session. Before we start, allow me to present a few matters of housekeeping that apply to all sessions here on out. This webinar is being recorded and will be made available after. Please use the question and answer box to type your specific. We may not have time to answer all the questions live, but the Secretariat will take note and pass these questions to the appropriate thematic session, or if applicable, we will consider these questions as part of our larger program of work. Note that we have 3 separate webinars following the completion of this last part of the plenary session today. These are separate webinars, which means that at the end of these special topic presentations, we have to choose one of the theme streams to attend. There are 3 different webinars for each of the streams, and in order to switch between the rooms, you have to leave this meeting and then rejoin the stream that you choose. You can choose either the orange or the green or the purple streams. If you have not already done so, you will need to register individually, and the registration is on at GCA webpage, that's www.aquaculture2020.ogr, and then navigate to program. After you register, you will get a confirmation by email, and you can use that link and that passcode to join. I will remind you about this again later. And finally, we want to acknowledge that the GCA is a hybrid conference. In Shanghai, we are joined by 500 participants attending in person at the South Island China Pilot Free Trade Zone Lingang Special Area in Shanghai. You can see them on your screen, and we'll have a team of local facilitators and chairs that will be with us throughout the conference. Hey, everyone in Shanghai, can you give us a wave? Hello. Good. For these sessions, we will have 3 special topic presentations that we expect of interest to everyone. The first is a presentation on small medium enterprise aquaculture in sub-Saharan Africa, which will be given by Harrison Charo Carissa, consultant in fisheries and aquaculture with the World Bank Group, and Lovin Kobushingi, a businesswoman working in the as the Chief Executive Director and co-founder of the Catchy Farms in Uganda. Speakers, please, the floor is yours.
Thank you very much, Maria, for the introduction. I also want to thank the organizers of this conference for having me and my co-presenter. We are very delighted to be here to go through this presentation on the SME and their roles in aquaculture. We have seen over the years that the SMEs in aquaculture are leading the way in many parts of the world. The 80%, around 80 million tons of farmed fish that is produced basically comes from the SMEs. And mainly some of these SMEs are not just one particular group, it's a group that contains quite a number of diverse people. And today I want us to go through this to see how we can use this situation that we have to make it better for the SMEs to play their part even better. What we see in most sub-Saharan African aquaculture value chains, we have a number of still small-scale on farmers who depend mostly on what they get from the government. But we also have quite a number of these are now getting into using small cages, and some have graduated to be small and medium-scale commercial farms that use a variety of production units, farms that are using ponds, circulation systems, cages. Is becoming quite a common thing to see in the continent. Now, the big issue that we want to address today is how we can pull up these small-scale pond farmers to bring them also into the category of people that can participate and gain from the growth that is happening within the continent. These small-scale farmers, they are dependent on selling their fish at the farm gate, which is not usually very, very effective. It is something that ends up hurting them because they are not able to access proper inputs, and they are also not able to access the markets that they should be able to access. Selling to their neighbors is not usually the best way, and so many actors need to become on board, but these farmers also will be able to come and start being able to access the market. For the large commercial that I'm going to show in a moment, these are farmers, these are the farmers that have been able to access some credit that they have used sometimes to have their own cold rooms and chilling facilities. And they also access to wholesalers very easily. Sometimes they even get depots where they can depot their fish, and this fish can actually go to the export market. Now, some of them also have their own farm outlets, which makes it much easier for them to function within within the conditions that we have within the continent.
Excuse me, Harrison.
Yes.
We cannot see your screen. You are not
You
sharing
cannot
your
see
screen.
my screen.
Yes, please.
Okay, this is very serious. Okay, sorry for that. So anyway, I'll continue from here. What I was showing you earlier on was you can see the screen now.
Yes, thank you.
Okay. So just a brief, I just want to to show you this. This is what I was presenting. What I've explained is already in that screen. Now I'm going to show you a variety of what we are calling the SMEs that are working very hard in the continent to make a difference. This, for example, what you have here, this is from the Victoria, this African blue farm. They are producing mainly tilapia in cages. As you can see, they have a mix of locally available materials that they use to produce this. We also have Yalelo. Again, you can see these are cages. This is one of the biggest movers. They use a lot of fish feed, which is quite useful for the industry. Here we have in Togo, we have small cages, but quite a number of them. Again, very, very effective in producing fish for the continent. These cages are much smaller and they are, of course, made by local available material. Another one that is worth looking at is Aquapro Agro-Industry. Again, you can see cages of, metallic and with these drums that they use to improvise. Then we have in West Africa, another one in Ghana. Here is very interesting piers. You can see the variety that we have within. So you can see innovation. Things are not the same. A flurry of activities, and this is something that we could encourage as long as it is done in a way that it is sustainable and able to ensure that the environment is taken care of. We have here.
Sorry, Harrison, please.
Yes.
The interpreter says that they cannot hear you well. Can you speak closer to the microphone, please?
Wow. Okay. So
Thank
let
you.
me. I have to hold it here. I hope now I'm being heard. All right. So this is another farm in Benin. This is a royal fish farm. They're doing catfish, as you can see, very highly intensive, quite useful when it comes to to using the space very, very well. Again, this is an indoor system, which means that they can take care of whatever waste that comes from here in a very reasonable manner. This is a RAS system that is quite common also within the continent. Here we have another system in Ethiopia, producing tilapia. Here you can see they have a very highly intensive system as well with aerators, paddle aerators. And what is good with this one is they actually gone to the end product. They're actually processing their fish. They have their own cold chain. And this is what we really need to see. But of course, it would be much better if there would be a possibility for government to organize themselves in a way so that they can be able to access the whole value chain without having to do everything by themselves. Here is another one in Malawi. They are doing catfish in an open system with hoppers, very effective as well. Another in Mozambique. This is basically in greenhouses, an indoor system producing tilapia. We have another in Kariba. This is Kariba bream. Again, this is using a mixture of ponds and the raceway system. Another indoor system here in Chobe bream. Again, you can see the kind of intensity that we have, which is what is fueling really the production that we are seeing nowadays from Africa. Harper and pond system being used by Volta breams is quite useful in terms of producing mass production of Nile tilapia, that monosex tilapia. Very useful again to ensure that the farmer gets the other farmers that are supported by this Volta breams can also access inputs from there. We have a number of very enterprising group here that is working on the fish feed. We have Scrating, Intreco, Ala Aqua, Ranan, and others that are very, very active in ensuring that fish feed that is produced is of the best quality. It's a lot of challenges because of lack of local available materials within the continent. And they have really tried to reduce the use of fish meat, which is quite good for the environment. We also have the likes of cattle farms, where Lovin is coming from, who are also trying to help the farmer and also the fresh tilapia market here to sell their fish. So this is something that Lovin will get back to in detail to explain what she's doing to ensure that farmers are supported, especially the ones that are not able to access the market by themselves. Now, sorry. What I want to looks like my system is refusing to do what it's supposed to do. Okay. So I will not, sorry, this is something very, okay, system refusing to work here. Sorry for this. So I wanted to show you, it's coming back by itself, that this development that we have is not just happening. There's a lot of investment that has happened to make sure that we are able to come to this level of development within the continent. So money is required. Money has been invested in the continent. And it is our hope that this money shall be available to the other producers as well, especially small-scale farmers that are still struggling with how to do things. Okay. Now, we have a number of farmers that are in this category who can grow the fish, but again, they don't know how to market it. We want to see how can these people also be brought to the place where they can market the fish that they're producing. To do this, we need to have an opening to the market. Market is very critical for us to be able to do this in a good way. Diversification of species is important. We are depending on very few species at the moment in Africa. And we also need to be able to standardize not only the products, but also the processes that are happening to ensure that whatever is being produced is of good quality, and also that the genetics is taken care of, that the fish are biosecure, and that we have proper data that can be used to develop the sector. This is a breeding program that has been happening. It is fueling a lot of development. We have had this happening in Egypt. We have also seen it happening in Zambia and other countries within the continent. Ghana is one of them. We are hoping that this is going to be a trend, but we need this thing to be organized in a way that everybody can benefit. Now, SMEs can play a very big role if they are allowed to function properly. And so we are encouraging that private public sector partnerships should be on board, and that we can have most of the breeding that happens at government and brood multiplication centers can be done by the private sector, and the government should continue their role in ensuring that the quality of this is taken care of. There is a surprisingly very weak market linkage to all this, whatever is going on, and we need to be able to have farmers supported with the market, that even these people that are doing the hatcheries, they should be able to know what kind of fish are we producing for this market. Now, this is a sad story that is still continuing in the country, in the continent. We have a few farmers that are still depending on very, very difficult situation because they don't have the proper feed. And sometimes the siting of the ponds are in a place that does not really help to keep the sanitary conditions better. So there's a lot of work that needs to be done. We have a few farmers that are trying to help themselves by, fermenting their own fish feed. This again is something that is not easy to do, but farmers are struggling to do it anyway because they cannot access the feed that is produced by the few feed manufacturers in the continent. Another big interesting thing that has been happening recently is the use of alternatives to reduce the cost of the fish feed. And here we are seeing companies like InsectiPro who are trying to use alternatives like the black soldier fly to ensure that they can produce fish that is easier, is cheaper for the farmers to access. So I will now let my co-presenter to go ahead and access this. Lovin, please welcome.
Thank you so much, Dr. Karisa. Good afternoon, good morning, good evening to you all. For SMEs to be able to work and support the aquaculture sector, we have looked at the market investment model, which is mainly customer-centered design. And when here we mean the SMEs are uniquely very important, and their role is helping smallholder farmers to source for immediate agriculture and fish farming technologies that are going to take the sector forward. There is need for mindset change, and here we mean innovations. We must work so hard to make sure that innovation is one very important aspect that can drive the sector forward. And innovations are very important in ensuring that the farmers are competitive, sustainable, and profitable, because we don't farm to just as a hobby, but we want to do farming as a business. We have seen that in brief, innovation can result into cost efficiency and provision of new products to meet specific customer demands. There is whereby farmers now have to think and do enterprise budgeting based on the resources they have at hand. And this has created a smooth transitioning from developing to full industrialization of nations without you doing enterprise plans, without you having your farm set from the first day of your production cycle. There is no way you're going to have profit because you are not prepared. And when you're planned properly, then you produce fish and you know where it's going to be marketed, and you know where you will buy your feeds, and you also know who the players in the market are. Next, please. Dr. Harrison, please show them the fish products. In Catty Farms, we have innovated various fish products, which we have worked with farmers from Uganda, and we have come up with various innovations in fishery. We don't only do trade in fish as a raw material, but we trade in fish with various products based on customer demand and preferences. We have all these nutritious and affordable products like meat, fish steaks, fillets, which are commercialized, fish, fried sausages from fish, samosas, and many more. And all this is part of the innovation that we have been talking about. And I see that innovation in small-scale industries can transcend in all areas, from production, finance, planning, marketing, and human resources. So you're not limited in any way. And we also advocate that for SMEs in Africa should have cooperatives. They should join cooperatives. Here, when we say cooperatives, we mean they should work together in profit-making organizations, whereby farmers can source inputs as a group, and then they combine their resources to import in bulk, for example, buying feeds, and then they have easy access to markets, easy access to financings, because when you're one, you don't have collateral, you don't have enough bargaining power, but with cooperatives and farm associations which are profit-making, you are able to lobby to the government for policy change. You are able to lobby for big resources that you need to be able to move forward. Next, please. Next, Doctor, yes. So we also look at the farmers taking advantage of the mobile apps that are there today, whereby these are helping farmers to have a market positioning and promotion of our products. Here we can have innovations in mobile, using the internet to market our produce, smart aquaculture, whereby farmers can monitor their production, they can monitor the feed, they can monitor if there are any diseases in their ponds or in their cages. They can also do bank transactions using the same technology. There is a lot of learning whereby now you don't have to travel far away to be in a workshop. So farmers can take advantage of having trainings online, also mobile apps for marketing, and many others. Next, please. So our experience in Kati Farm is that we work with small-scale farmers, and we started with one product, which were the fish sausages in 2012, and it promoted the business because every other product that comes on board is on demand. So when the customer demands, you have this, then we go forward and do market studies, and then we are able to bring the product to commercial scale. We have, for example, we do smoking, commercial smoking of fish using modern safe smoking kilns, which are healthy. We also do work with farmers to make sure that we have constant supply, and we also encourage going industrial level. We employ many women and youth in particular, and we do retail, all sell our products through mobile. We have 5 shops in Kampala which do distribution and marketing. Next, please.
Excuse me, 2 minutes.
So lastly, Kati Farms, as I've already mentioned, we also took the same route, and we have, as an SME, an example of an SME in Africa, have realized that for African SMEs to participate equitably in aquaculture, there is need for credit, they need to access finance, which is really very, very, very important. And this finance should be affordable finance. And it should be appropriate, it should be consistent and accessible. And we should also access high value markets to remain in this business. Also, there is need for encouraging the aquaculture innovation platforms, which we see that they will help the continent to communicate to the farmers communicate to each other, learn, get experiences, and trade. And also farmers need to improve input availability and markets, and improving visibility, sustainability, and growth. There is need for trade markets that are lucrative. Now we should do more market research on where we should sell our products. And I also advocate for gender-sensitive training programs, which should be conducted to increase women's roles and extent of participation in aquaculture value chains. And lastly, more research is needed to develop better quality seed and cost-effective methods and locally available feed resources. Thank you so much for your listening.
Thank you, Dr. Thank you, Dr. Carissa and Lokshin. Very informative and interesting presentation. We hope to see African aquaculture increase in the next years. Thank you for sharing with us. Our next presentation is given by Dr. Wander Brumet, Senior Specialist from the World Bank, and Flávio Corsin, Director of Partnership at Aquaspark, a leading investor in sustainable aquaculture. Their presentation is on investment in aquaculture. Gentlemen, please, you have the floor.
All right, let me just dive right in. There's real potential for long-term economic growth and job creation in many developing countries in the seafood industry. for which infrastructure such as roads, cold storage, processing capacity already exist and could be expanded, but for the lack of reliable supply that capture fisheries cannot sustainably generate. According to the OECD, FAO, and World Bank estimates, seafood supply, especially of reasonably priced whitefish for lower and middle income consumers, is far from satisfying demand. In an effort to capitalize on this large and growing market for the benefit of local producers and economies, there's been a lot of government, donor, and international financial support to aquaculture development over the years. Some of this has been helpful. A large amount of it has been a waste of money. Today I would like to review the rationale for government investment in aquaculture and provide some guidance on what governments can realistically do to support aquaculture innovation. There we go. Everybody knows that aquaculture, just like other types of farming, can be a risky business. There is an old joke that all you need to make money in aquaculture is a lot of money. In fact, a known amount of risk can be built into a successful business model. The real problem is volatility and unpredictability. You can see on this graph from the insurance industry that the number of farms losing money in the relatively high-tech and well-managed salmon industry, for which we have a lot of data, can vary between near 0 to 100%. On the bright side, most of this volatility and risk is manageable. Diseases, about 21% of losses, can be dramatically reduced through the application of known biosecurity measures. Frequency losses, which are the result of poor planning, bad luck, can be significantly curtailed through improved technical design that, importantly these days, incorporates redundancy and climate resilience. The ultimate driver of unsustainability in aquaculture is the lack of finance to adopt best practices. Globally, aquaculture is a medium-scale business. And as Harrison's data showed just now, medium-scale companies have a net present value of about $3 to $5 million in Africa. It's smaller in Asia, a lot of smaller companies where temperatures are generally higher, there's more water, and infrastructure is more suitable. But because it is mostly local businesses that operate rather idiosyncratic and often ad hoc production systems, they periodically suffer large losses that make commercial banks reluctant to lend. Consequently, over 90% of finance for aquaculture comes from personal savings, meaning that virtually all farms are undercapitalized. Cutting corners by buying less efficient technology and externalizing environmental costs are ways to save money but increase risk at a variety of levels. So if we go back to the insurance loss graph, you can see how over time the industry is moving in the right direction. With the application of new technology and best management practices over time, volatility and total losses are declining. This data from Lenfest further illustrate this point. More sustainable and less volatile aquaculture sectors are in the upper right, while less sustainable systems are in the lower left. Sectors that appear in blue are relatively new, while those that appear in red have increasingly improved their technical intensity to improve efficiency and reduce losses. There remain large opportunities to improve. We don't have good data on aquaculture, but for agriculture in general, the yield gap, that is the difference in productivity between research station trials and actual farming systems, is nearly 2 orders of magnitude. Room for improvement is also reflected in labor productivity data. North America, and to a lesser extent Europe, are outliers due to the restrictions that have been imposed by the environmental lobby and wealthy owners of waterfront property. But a 2 to 3-fold increase in productivity is still feasible in Asia, where most of the world's fish are grown. To summarize, the aquaculture industry finds itself in a chicken or egg conundrum, where the industry cannot access the finance it needs to reduce risk and environmental impacts because of its high risk profile among financiers. Public sector investment in aquaculture focuses on breaking this conundrum by lowering the cost of capital so that medium-scale farmers can increase their application of best practices, release the potential for growth in the seafood industry so that it can continue to modernize, minimize its environmental footprint, and reduce economic pressure to overfish natural resources. Work that was done by the Inter-American Development Bank and the World Bank illustrates why this is important for poverty alleviation and economic development. If we can facilitate investment in smaller scale businesses, as opposed to just letting the big companies proceed alone, we can add more, more equitably to GDP and double the amount of poverty alleviated. Implementation of best available aquaculture production and management practices would reduce risk and manage volatility so that these farms become, one, more profitable to smaller scale to encourage SME investors' first entry into a growing industry. And two, make these farms bankable so they can grow to meet demand and create new technology and markets. In the absence of systematic public sector engagement, the boom and bust history of aquaculture will be repeated for better or worse. Market demand is growing and sustainable capture fisheries are yet a dream in most places. Aquaculture producers respond to market and price signals just like everyone else. And in the absence of sustainable and affordable alternatives, will cut corners and incur the wrath of Mother Nature and the loathing of bankers. If best practices are eventually mandated by law to minimize these negative externalities, only wealthy corporate investors will remain economically viable, able to respond to consumer demands for affordable quality seafood while respecting environmental safeguards. To level the playing field and create opportunities for the smaller scale operators that are the engines of growth in most economies, best practices need to be made available, a clear role for public sector finance. However, direct public sector finance to farmers is politically difficult to manage and subject to abuse. Nevertheless, there are a number of things that government can do to help. Such mechanisms as loan guarantees, subsidized crop insurance, creating financial incentives through competitions, such as the World Bank Ag Results Project and the F3 initiative organized by the Anthropocene Institute at the University of Arizona, UMass Boston, and Shanghai Jiao Tong University, among others. Implementing national and sub-regional biosecurity measures, bringing in experts and educating farmers in best technology, building necessary infrastructure and establishing the rules and limits to growth have all been tested and proven effective. By doing these things, government can help break the chicken or egg cycle and release the power of private finance for the betterment of fish farmers and local economies seeking a better future for themselves and their children. Thank you for your attention.
Thank you, Randy. And thank you, everybody. Good day. And thank you for giving me the opportunity to talk about investing in private sector investing in sustainable aquaculture. Let me know if you can see my screen.
Yes.
Yeah. Okay. Very
Thank
good.
you.
Okay. Fantastic. So I work for Aquaspark, and we are an impact investor. Well, we are actually an investor that go after competitive returns, but we believe that doing that through sustainable aquaculture is the best way to achieve those competitive returns. We are all great believers in aquaculture and the potential of aquaculture. So I'm preaching to the choir, but I wanted to share this slide from an article that came out last week on Nature that shows how, when we talk about the footprint, greenhouse gases, water footprint, land footprint, actually aquaculture performs better than chicken, and it's the beige line that you see there, the vertical line. But in some cases, it's not the case. So, for example, with the tilapia, the performance is actually slightly worse in average than a chicken. And then we all know that tilapia is an omnivore and is a fish, floats, and it doesn't need to thermoregulate. So why is that? And we believe that that potential for the species and for the systems has not been unleashed yet. So what are the challenges that we are seeing? Again, a lot of these things might sound quite familiar, but we see farming systems that are actually still traditional and a little bit antiquated, if you want. Genetics, the potential of genetics has not been exploited. Only 15% of the aquaculture animals that are farmed now are they underwent some form of selective breeding. So, which means that the potential, some form, which means that potential is not just the 85%, but is also for that 15% to actually exploit more the genetic potential. For example, replicating what has been done in chickens or other forms of livestock. Feed ingredients, very traditional, wild-based, agriculture-based, with some environmental and social impacts associated with that. Digital tech, so the aquatech, the use of technology and data is actually, the uptake is very limited. We are calculated that more or less just about a bit less than 100,000 farmers are using digital tech. 100,000 farmers out of the tens, if not hundreds of millions of farmers out there. Limited alignment and collaboration, so a lot of fragmentation, also at the production side, but on the production, but also throughout the value chain. Animal welfare is not considered in a lot of the conversations when we talk about sustainable aquaculture, in spite of being asked by several consumers and being part of legislation in some of the countries. Antimicrobial use, I mean, 79% more antibiotics are used in aquaculture per kilo compared with the humans. So maybe there is something that we can do there to reduce the use of antibiotics. And we have seen that it is possible, like in the salmon industry, for example. Limited access to finance, and Randy mentioned about 90% of the producers actually having to rely on their own savings, which then limits innovation, but also fragmented markets, a lot of middlemen, a lot of distributors, and that creates a complexity. So what do? I mean, we make investments. So we have 2,000 companies or 2,000 deals, as we call them, in our pipeline, which are basically companies that we are tracking, of which 25 of these are active, which means these are companies in which we are looking to potentially make an investments in the short term. You see here some of the trending topics, but I'm going to go a bit more in detail in some of those, so you understand where the private interest is when we talk about investment. Before we go there, just a bit of a geographical description of where are those deals. And you see they are global, but interestingly, we have only 16.5% of the deals coming from the Asia Pacific, where you have 90% of the aquaculture production. And that's a reflection of a lot of startups, a lot of energy that is active in Europe and in North America. But of course, there are also farming operations a bit across the globe. In terms of what are those deals, those 2,000 companies, we see more than 50%, as you would expect, around farming, but also farm technology, what I said before, aquatech, and feed ingredients play a key role. When we look at the farming method, and that 50%, we see recirculation systems, we see net cages, we see land-based, also some ponds, but basically the innovative systems, recirculation systems, land-based systems, taking a bit more priority in our pipeline. Let me go a bit more in detail about some of these categories. Okay, so we see that in terms of systems, there is an increasing traction towards closed systems and innovative filtration. When I say closed systems, recirculation systems has been all over the news, of course. By some estimates, it's between 10 and 20% of the industry by 2030 will be in recirculation systems. You might argue that some of these estimates are quite optimistic, but there is a clear trend associated with investment from companies like ourselves towards making a transition towards recirculation systems. And that investment reflects also in shrimp and other marine fish. We see also traction around innovative filtration. So recirculation systems use biofilters, and they use a bunch of things ozone, UV to deal with the biofilter. We are seeing traction in electrochemical filtration that basically replaces the biofilter with an electrochemical process of removing waste, but also the use of microalgae so that the water from a recirculation system goes through microalgae to produce a product that then can be marketed instead of just being a service that is provided by the biofilter. We see a lot of traction also in offshore farming, huge investments required in that space. Also, ponds are coming to us, more pond systems that are trying to become increasingly closed, so keeping biosecurity a bit more. And Africa, we have seen from Harrison and Lovin, there is quite a lot of work happening there, but for us, it's a bit of a special case. We are setting up a specific Africa fund to invest in aquaculture in Africa, because there we might finance more traditional systems, which maybe we will not finance in other geographies. I mentioned Aquatech a couple of times, and this is the safer way for an investor to deal with the traditional farming. So instead of working in ponds as they are and investing in ponds, we work towards the services that are gonna make those ponds more efficient, therefore having better access to finance, better access to insurance, better technologies that can improve efficiencies. And depending on what are the farms, you can have an efficiency improvement between 5 and 28% in FCR, for example. So a lot of digital technology, but we see most of this traction is coming from farm-based management tools. You know, the app that helps the farmer collecting data from different sources to take decisions. We see also traction for animal welfare technologies that can be plugged in as a better way or to increase. There is the link to mortality and health, but there is also the animal welfare per se that provides a benefit to the farm, but also to the biodiversity around the farm. Alternative feed ingredients is also reaching a lot of attention. The alternative protein market by 2026 is going to be more than $4 billion, which is still small as a proportion of the whole market, if you want, but it is considerable market, which is again attracting a lot of attention. Insects were mentioned around in Africa as well, but it's a global development. By some estimates, by 2030, the insect protein demand will be around 500,000 tons. Single cells protein that is now more than $180 million in value. These are bacteria that produce the same amino acid profile, the same protein that you would find in fish meal. I think around 98% similarity. Therefore, instead of using fish meal, you can use for the proteins, you can use these single cells. But for the omega-3s and the oil, as a fish oil replacement, we see traction with the microalgae and with the seaweed as well. And I'll talk a bit more about seaweed in a bit. Again, traction in better health and alternatives to antibiotics. So I think it was the World Bank that estimated that the aquaculture sector is losing $6 billion every year to disease for prevention, for treatment, and for the actual mortality. We see traction in diagnostics, some traditional diagnostics as well, but really companies that want to bring more diagnostic to the sector. Again, Aquatech for prevention and control. How do you use data to know when something is coming and how you have to react to that something, with that whether it is a disease or any poor productivity development in the farm. A lot of traction on gene silencing as an innovative way to control the development of diseases within animals, but also bacteriophages. And you see here this is one of our companies that is instead of using antibiotics, we use the natural enemy of bacteria, which are those bacteriophages, which are viruses. And when you select the right group of these naturally occurring viruses, then you can have a treatment for a bacterial disease without needing antibiotics.
2 minutes, Flavio.
Thanks. You see a lot of traction for upcycling of fish waste. So there has been a lot of effort towards doing more with the waste. But actually, there is now with enzymatic hydrolysis, you can have a higher value oils and higher value proteins, which instead of having consumer packaged goods, becomes more of business to business companies, which then for the health and beauty, nutrition, and the premium animal feeds. Market access, again, Aquatech to providing market access, shorten the supply chain, and have branded products for both domestic and export market. Wave of deals, and they are driven, instead of having cold water species, high prices, basically direct consumption for humans, much more applications towards immunostimulants, biofuels, and textiles. And we see a lot of work happening in this direction and a lot of seafood. And the market is going to pull through blended finance.
And Flavio, indeed, Professor Zhang, you have the floor.
My name is Yang Dengjie. I come from sciences. To be here as I invite the speakers and integrated multi-trophic. I will give you a brief fed agriculture in China. The agriculture activity is classified into two types. The first one is the fed, the unfed agriculture, such as the bivalves and the seaweed, in unfed natural food to meet their nutritional requirement, and they will feed. Agriculture in China. As we all know, China is the largest agriculture producer in the world. Agriculture production accounts for nearly 70% of world agriculture. The agriculture production reached more than 50. Compared with other countries, the agriculture in China is carrying rich diversity, multi-trophic levels, and higher fed rate. Since 1950, it shows the marine culture developed last 40 years, reached more than 21 million tons. And fed shellfish and seaweed account, however, need to be addressed, such as the limited space due to the etc. Potential solution efficiency per unit area. In the second part, I'm going to share you some experience of the practice of sustainable and fed agriculture in China. When we talk about the agriculture, people always argue about the agriculture as a pollution, as consider it after agriculture carrying capacity. The definition of the capacity or population in a defined area in relation to available food resources. Actually, the agriculture plays an important role in the environment. Take the bivalves as an example. As we all know, bivalves are always considered as the ecosystem, the strong capacity to filter the seawater, and overstocking condition will cause the top-down control for phytoplankton webs. In addition, biodeposition process will cause the underlying sediment that remain and need to be paid. To improve the production efficiency of main agricultural product system called China Agriculture Research System in 2007, shellfish and seaweed are two species. Scientists are employed for specific research on breeding, processing, and economics. I'm one of the research scientists of the shellfish research and sustainable management. Agriculture carrying capacity can be classified into 4 types, dated in a particular area or space. Secondly is the production carrying capacity. It is the stocking density at which harvests are making or farm density above which would cause unacceptable ecological impacts. Then finally is the social carrying capacity, culture that can be developed at which the society as a whole is willing to accept. So far, what we usually called the agricultural carrying capacity, and in recent years we start to move the capacity. The methodological approaches to study agriculture carrying capacity can be summarized from the pelagic and benthic. So several approaches. The NPZD based ecosystem dynamics used method. Then in the part 7, give you a case study on the large named Sango Bay. I think maybe some of you visited there before. The bay located in Shandong Peninsula with the total area about 140 kilometers square. Marine culture industry for more than 60 years with annual production about 700,000 species, includes oyster, scallop, kelp, and collect the necessary data for the several different field courses, in situ experiment, long-term continuous some data from the individual level, ecophysiological research on oyster. I will not explain it in detail. The data helps us better understand the ecological function. Another important component for the carrying capacity is the individual growth. Based on the dynamic energy emission of 3 kinds of bivalve, Manila clam, and such individual growth model and production prediction. Then as a key driver, the hydrodynamic submodel established based on the ROMS model through the collaboration of and Institute of Marine Research. Then through coupling all the hydrodynamic and biogeochemical model, system model, based on this model, the production and phytoseeding density is predicted. If the economics is being taken into consideration, it is suggested that the suitable culture density of the oyster meter square. Then let's back to the second potential solution area. One of the best solutions is integrated multi-trophic agriculture. That is normally we call the MTA in brief. The definition of MTA is a system in which waste materials from one species serve as food or fertilizer for the next, creating the loop of healthy and sustainable agriculture. The term of MTA was first mentioned at a workshop in Canada in 2004. Together with Dr. Jack Taylor, Dr. Terry Troffin proposed to combine integrated agriculture and multi-trophic agriculture into integrated multi-trophic agriculture. The concept and the practice of integrated agriculture is well known in inland and originated in China with a long history. In the middle of the Ming Dynasty, mulberry trees were planted on the base of fish pond in the Pearl River Delta region for carried out the integrated cultivation of fish, silkworms, and crops. This is the earliest integrated agriculture in commercial scale in the world. Recent years, MTA developed very fast in several countries, such as China, Canada, Norway, South Africa, Israel, etc. In Canada, the scientists developed the salmon, blue mussels, kelp MTA in the Bay of Fundy. The results showed that the increased growth rates of kelp and mussels cultured in close to fish farms compared to reference size reflect the increase in food availability and energy. To promote the industrialization of MTA, the National Science and Engineering Research Council set up the Canadian Integrated Multi-Trophic Agriculture Network. This network collaborates several institutes, universities, and researchers in related areas to study the key process and the mechanisms of MTA system. In Norway, the government funded 6 successive MTA special projects from 2004, and scientists explored the MTA practice of mussel, scallop, and sugar kelp at 7 farms. The results showed that the kelp at the MTA site grew faster than control site about 1 kilometer away. And the evidence from the stable isotope and fatty acid tracer showed that mussels and scallops can effectively utilize the waste fat and feces generated during the salmon farming. Then let's back to the MTA practice in China. Based on benefit from the advantage of species-rich diversity and multi-trophic levels of agriculture in China, several kinds of MTA systems have been developed in China in the past several years, such as the coastal MTA, pond MTA, land-based MTA, and also the rice fish integrated farming system in freshwater. Since I'm trying to introduce the unfed aquaculture topic today, so I will introduce 3 typical unfed species-based MTA. The first type is the bivalves and seaweed MTA. The key point for this system is the interaction of bivalve, phytoplankton, nutrient, seaweed, and the result of production carrying capacity. In this system, the bivalve and the seaweed share the same long line facilities and benefit each other. The suitable density of the oyster and seaweed is 150 and 50,000 individuals per hectare, respectively. By this way, the net income of each MTA unit is about 4,000 Chinese yuan. That means increase more than 40% compared with the monoculture. The second type is the kelp abalone cucumber MTA. In this system, all the animals share the same long line as well, and the seaweed serves as the food for the abalone, while the dissolved and particle waste generated by the abalone are absorbed by seaweed and the cucumber. By this way, the farmer can get extra 2,000 Chinese yuan per long line. The graph in the right shows the carbon budget in this system. It shows that the CO2 released from the respiration and calcification from the abalone and the cucumber can provide more than 50% of the requirement for photosynthesis of the kelp. And also the species and debris from the abalone and the kelp can support more than nearly 70% of the food source for the cucumber. All the functional groups benefit from each other, therefore reduce the negative environmental effects of large-scale abalone aquaculture. The third type is the seagrass-based clam and conch MTA. In the Chudao area of Sangou Bay, the seagrass covers more than 200 hectares. The Manila clam live in or near seagrass beds with a very high density. The harvest activity of Manila clam by tours will destroy the roots of seagrass. But if the Manila clam cannot be harvested, that means the farmer cannot utilize the resources effectively. In order to break the dilemma situation, the conch was enhanced to prey on the clam based on the ecological carrying capacity. The pickup harvest operation of the conch is very easy for the farmers and benefit for protecting the seagrass. By this way, the farmers can get more money because of the higher price of the conch than clam. The CO2-induced climate change is one of the biggest issues facing the world today. The graph in the left is the very famous killing curve. This curve records the CO2 concentration in the atmosphere since 1958, and the numbers has already reached more than 400 ppm now. In 2010, Academician Town came up with the concept of carbon sink fisheries. The definition of the carbon sink fisheries is generally referred to the fishery production activities that can facilitate biological absorption of CO2 in the water and therefore remove carbon by harvesting. The concept of this concept builds the bridge between unfed aquaculture and the CO2 issue. The graph in the left shows the role of shellfish and seaweed in marine carbon cycle. The seaweed can transform the dissolved inorganic carbon into organic carbon by photosynthesis, which can decrease the partial pressure CO2 in the seawater. The shellfish utilize the carbon in 2 ways. Firstly, they use dissolved biocarbonate from seawater to generate calcium carbonate shells. And secondly, they utilize the carbon through filter feeding activities, which can strongly affect the amount and composition of particulate organic carbon. This is some detailed data from the carbon budget research on the scale during a farming cycle. The results showed that nearly 30% and 40% of the utilized carbon were removed from the seawater in the form of shell and soft tissue and biodeposition, respectively. Regarding the macroalgae, recent studies show that it could sequester 170 millitons per year globally with a range of 60 to 260 millitons per year. Nearly 90% of this sequestration occurs through export to the deep sea and the rest through burial in coastal sediments. The assessment of the ecosystem service value shows that the value of food prevention service and climate regulating service provided by the IMTA system is 2 to 3 times higher than monoculture. Dr. Ken Sherman from NOAA, who is known as the father of large marine ecosystem, made some comments on IMTA developed in China in 2012. He said the pilot IMTA project proved to be highly energy efficient and optimized the carrying capacity of coastal embedments while improving water quality, increasing protein yields, and through carbon capture, contributing to mitigation of the effects of climate change. To further promote the IMTA practice, the platform covers the government, industry, institute, university, and customer were established in recent years. Some experience or lessons I can share you is that the powerful support from the government is very important during the expansion of the IMTA. In addition, several international training courses were organized by us for the knowledge sharing of IMTA all over the world.
Dr. Zhang, 3 minutes.
In the last part, I will share you some idea on the way forward. In January 2019, 10 governmental departments, including the Ministry of Agriculture and Rural Affairs, have jointly issued a guideline on the green development of aquaculture industry. As the important component of the aquaculture, fed aquaculture faces new opportunities and need to develop more efficient way. One of the possible way is to improve the engineering technology. The solution is to upgrade the traditional anchor with a multi-function ecological anchoring system. The traditional anchor is used made of the woods or stones and plays a single functions for the fixing the long line, while the new ecological anchoring system is designed for integrated the function of artificial reef with anchor so as to enhance the sea cucumber or other species. In 2020, total 200 ecological anchors were deployed on the long line system, and the implementation effect is still monitoring. The second possible way is to strengthen the cascading function of benthic species in IMTA system. So far, the benthic functional groups are the weakness of IMTA system. The sea cucumber is normally used as the cleaner animals in the IMTA system, but the estivation and requirement for the special sediment environment conditions limit the cleaner functions of the sea cucumber. It is needed to explore more efficient and more appropriate species to strengthen the cascading function of the benthic groups. Apart from the sea cucumber, 3 kinds of worms coming to the site of our studies and will be further explored. One more possible way is to improve the intelligence level. Start from the 2018, a project named Intelligent Management System for Integrated Multi-Trophic Aquaculture was funded by the European Horizon 2020 program. This project is to develop the multi-sensing and multi-functional management platform for sustainable IMTA. And it brings together 21 partners from 12 countries. Sango Bay is selected as one of the 6 pilot sites. And this work is still ongoing and look forward to the application of the intelligent management system. When we talk about the IMTA, it should be clear that IMTA is a concept, not a formula. The scope of the IMTA concept is extremely broad, flexible, and evolving. It can be applied worldwide to open water or land-based system, marine or freshwater environment, such as the aquaponics in freshwater, and temperate or tropical climates. The most appropriate IMTA depends on a number of factors, such as environmental, biological, physical, as well as governance conditions, etc. The combination of these factors will lead to different choice in the design of the best suited IMTA system for any specific location. Recent years, several workshops or conferences set up the IMTA special session. That means IMTA concept has received more and more attention and will continue to be more powerful in the future. At the end of my talk, I'd like to summarize my presentation. Carrying capacity assessment is a useful decision-making tool to ensure the sustainable development of unfed aquaculture. Unfed aquaculture has the potential to serve as carbon sequestration. Integrated multi-trophic aquaculture is a promising approach for recycling food and energy to increase profitability while mitigating environmental drawbacks. The implementation of IMTA is attractive conceptually, but in reality, there are a number of considerations to be paid more attention, particularly at commercial scales. Thanks for your attention.
Thank you, Professor Zhang. Very interesting to see the Chinese efforts in progress in this sustainable aquaculture production system. Thank you very much for sharing with us. Well, thank you for all the presenters. This concludes our plenary session for today, and we are now going to move into one of the three parallel sections. In the orange stream, we'll talk about aquaculture systems. In the green stream, we'll talk about feeding and feed. And in the purple stream, we'll talk about policies, planning, and sectoral governance. Remember, if you have not done so, you need to register for the webinar you wish to attend. It takes only a few seconds from the conference website. Kindly note that you cannot switch directly. You need to leave this webinar and rejoin one of the parallel sections. See the program online for details of the sections and instructions on how to register. For the local participants, please turn your attention to the local moderator who will direct you to the various rooms. We will be starting in a few minutes. So now you need to close out of this webinar, press the leave button on the button to leave, and then rejoin one of the three parallel sections. You should receive a confirmation email. If you have any trouble, go ahead and register again, and you will get the link and the passcode. The passcodes are the same for all the webinars. Okay, so please go ahead and leave, and we'll see you again in the parallel sections. Thank you very much for your attention.